Hello, welcome to Applied Chemistry Lab videos of IPCC course. Myself, Dr. Kiran Kumar P, Assistant Professor, Department of Chemistry, ATME College of Engineering, Mysore. Today's experiment is on the determination of viscosity coefficient of the given liquid using Ostwald viscometer. So the entire session includes the theory, experimental demonstration, and observation and calculations. Determination of viscosity coefficient of a given lubricant or a liquid using Ostwald viscometer. Viscosity is a measure of resistance of a fluid to flow. It defines the friction within a moving fluid. A fluid with large viscosity generally resists the motion because it gives a lot of internal friction due to their molecular structure. So here is an example. If you consider water and lubricant, any lubricant for that matter, where water is having low viscosity, the internal frictions are low. As a result, the liquid flows more easily. Whereas in this case, it has high viscous, the movement or there will be due to internal friction the of the molecular structure of that particular oil or a lubricant, the movement is restricted. This is another example where vegetable oil, motor oil, dish soap, syrup and honey. So you can see the honey is more viscous when compared to vegetable oil or any other liquids. So the viscosity and coefficient of viscosity is defined as generally the tangential force per unit area required to maintain a unit velocity gradient between two successive layers of a liquid situated at a unit distance apart. So the flow of liquid at a unit distance are kept apart uh, is whatever the tangential force required is called as coefficient of viscosity. So this is an experimental demonstration. This is our Ostwald viscometer where we have highlighted it to make it clear, make it more visible. We have filled the known volume of a liquid, organic liquid, up to this mark. And there is a mark between A and B. We call this as A and mark, B, upper mark and lower mark of a Ostwald viscometer, which is connected here. So the typically the liquid here or any liquid, or it may be a lubricant or any other oil is blowed from here, allowed to suck from here. So the liquid is allowed to suck till this mark A. You can see the liquid is moving upwards. It fills this bulb. Once it reaches above the point A, put a stopper on when it reaches the point A. Note down the time taken for the flow of liquid between A and B. This is the unit volume, unit area. More is the viscous or more is the viscosity of a liquid, more greater will be the time taken for that particular liquid for flowing from A to B. This is due to their molecular structure. So now you can see the time taken for the liquid to flow from A to B is around 80 seconds. Note down or convert it into the seconds and note down. After this trial, you just rinse the Ostwald viscometer with acetone. Acetone. The reason is to make sure all the lubricant or an oil has been cleared. Now, as a reference, the same procedure is followed. Dry the viscometer, and for the same procedure, you carry out with water, known volume of water. You take water up to point C, known volume, suck the water up to point A and allow it to flow from A to B. Note down the time taken for water to flow from A to B at that particular temperature. Once it is done, this is the tabulation column. You can see here the organic liquid, note down the number given, and trial 1, trial 2, trial 3, trial 4. Note down the 4 different readings and it should be in seconds. Take the mean value of the liquid to flow from A to B. Similarly, measure after drying, measure the time taken for the water to flow from A to B and take the mean value for that particular water. Initially, to calculate viscosity coefficient of a given organic liquid, any liquid for that matter, the laboratory temperature or the laboratory temperature at which the experiment is carrying out is need to be measured. Note down the temperature. Density of the given liquid, it will be given, note down at that particular temperature. Density of water, even that will be given to you, note down at that particular temperature. Viscosity of water, again it will be given to you, note down at that particular temperature. Now, you know the value of time taken by the density of liquid, viscosity of water, time taken by the water, and density of water, also time taken by the liquid. You can calculate the viscosity of liquid at this particular temperature. So this is how Ostwald viscometer is used to calculate or to measure the viscosity coefficient of the given liquid. This is it is. The formula used, Euler's formula. Here you can see the time taken for the liquid to flow from start mark and stop mark. When the liquid reaches the start mark, switch on the stopwatch. When it comes down at stop mark, stop the stop. Note down each reading. This is how we can measure the viscosity coefficient of given organic liquid. See you in another video of applied chemistry lab videos. Thank you very much.